so different in all these different studies? Is it that the racial compilation was different from this study? Is it the age? Is it the marital status? We make a lot of assumptions. We're like, well, based on their sample was really young. Our sample is old. So maybe it's different, but we're speculating that age is the moderator. We don't really know. It might have nothing to do with age. When you're doing these lit reviews, I want you to think outside of the box. Inside of the box is saying, well, I'll do one more with the sample I gather on MTurk, and that will be the one that helps us know which way this really goes. Instead, think about several moderators and test several moderators. Think about the context of why it might be different. We do not give ourselves enough credit in our field for how smart we are. And I don't mean that sarcastically, you have a lot of, I bet most of this room has close to 1,000 hours of you watching really intense situations happening right in front of your eyes that most of the community doesn't even know is happening at all. You have a lot of direct observation, a lot of direct experience. You've read a lot. You've observed differently. I don't mean this in a negative way because I love my wife so much. But every now and then, we'll be talking about things, and I notice I observe situations differently than my wife observes them. She doesn't notice or catch or see, and at the end of it, when we go back home from a family gathering, I'm like, wow, did you? No, I didn't see that at all. Are you sure? What's that? Well, with this, and then this, and you're different. You have been changed forever. You can never be the person you were before your message program. You have all of that knowledge where you understand things a little bit differently. I believe that we have a huge advantage. And again, I don't mean this in a mean way because I love our family studies colleagues. But I think we have a huge advantage over them because stuff that might be sort of almost obvious to you because of how many people you've worked with in different situations, especially when you start to get a niche area clinically, then it even grows exponentially. But what you've observed, what you know, other people don't know that. And you telling them, they went, oh, it's a therapist, my therapist, my old friend thinks this and that. But they don't believe you, and it's not going to affect policy until you study it, until you test it. You know every one of you has pathways in your mind for how would I help some teenager who just got caught smoking marijuana and he's selling cocaine at school, smelling it too, I guess, but selling cocaine at school to pay for his marijuana. If that kid comes in, you already have all these pathways in your head of what you want to do to help this kid, don't you? First I need to do this, and then we're going to do this, and after that, then we'll get here. By the time we get to session 2 or 3, we'll maybe be around here. I'm going to need parents for this, so I'm going to talk to the school about, but that's just, you don't even have to think about it. For other people, though, that's like rocket science. So test it. Test the pathways that you know. Test the moderators that you know. And I think we could explode, literally explode in the next decade or two in what we know. If we were to put all this clinical wisdom and actually test it, because we don't believe it, right? If Sue Johnson says attachment is the most important thing ever, and Schnark is in the room, be like, no, differentiation is the most important thing. No one believes the therapist saying whatever therapists say until we test it, right? When we test it, then we're like, oh, so this is, and by the way, we want to test it as an interaction effect, right? Test with and differentiation and context. Use what you know to help our field, please. I really think that something I feel strongly about, we are wasting so much knowledge because most of us don't test what we know, and most of us aren't able to. I know Caitlin knows a lot of things clinically that I don't know because she's had good clinical experience I haven't had. She's worked with people that I don't know, and she learned things from that she can come up with research questions from that I can't come up with. But she can, and if she has experienced it, if she's doing some good substance use work, because that happens a lot over there, she probably could come up with questions that most people wouldn't be able to come up with based on her last 75 hours of substance use work. And that could be really meaningful to change how we do substance use work. Maybe we don't have to take so long before we get to positive outcomes. Maybe there's more effective ways that are more productive. Maybe there's ways that are safer. But until, she maybe already knows it. And she doesn't really recognize that it is knowledge, but it is something that she knows that some of us don't. And it's the same for every one of you. Test what you know, monologue, over. Please do. All right, so moderators, we test in the context of X and Y. That association is all across the board. Positive, negative, or nothing. Mediation, your mediation flag should pop up when over and over again, every time we know, yes, this generally leads to these outcomes. If that's the case, then the next step in our program of research is how. Well, if this is linked with that, how? What are the underlying processes that get us there? Clinically, specifically, how do we get from here to here? How can we test how we go from point A to point B? So hopefully those are your mediator and moderator red flags for when we should jump in and test those. With mediation, we're really doing super well on time. I cut out some videos, cut out the Kahoot, and I am pleased with where we are. Am I not going too fast? Are we okay? All right, this is good. All right, so mediation. There's lots of different ways to test mediation. If I can just skip to the very end, you should just bootstrap. The others are more for historical knowledge about what we were doing over the last 50 years. Because you're going to review those papers and your co-authors might say, well, why don't we do this? I want you to know what they are, but I don't really want you to do them. So here they are. Has everyone got that? The way we test it is how? Bootstrap. You're going to bootstrap it. All right, so Barron and Kenny, in that paper in 1986, they talk about 4 steps, which is 4 different regressions. Which hopefully you can already understand. 4 regressions is not as good as just one map analysis, or one SEM. No reason to do 4. But that's all they had back then, so that was a good way to do it. Some people test mediation literally just in an SEM model. You just specify this predicts this, so they don't necessarily test the indirect effect. If they just show they're all significant from A to B to C to D to E, then must be a significant indirect effect. It's not as good of a way. There is a little phase in the earlier 2000s where people were using SEM models to constrain the direct effect from the predictor to the outcome, constraining it to see if it's significantly lowered when we included the mediator, but nobody does that anymore. You might not even see that much. Sobel test, does that sound familiar? Sobel test is a really easy way. It's super easy, so it's tempting. And then there's the Prodklin method. The Prodklin method is something better than the Sobel test, but David, what's his name? McKinnon? No, David. Is that his name? It's David Kenny. McKinnon is the last name. But McKinnon proposed this method better than the Sobel test called the Prodklin method. But when he tested the Prodklin method versus bootstrapping, and this was a method that he had websites for and he was personally profiting from, he took them all down partway through my PhD program, which I thought was super respectful and like really high integrity, because it was a pretty good way to do it. It's like, well, if it's not as good as bootstrapping, I'm going to take it down so nobody can do it anymore. Interesting. Those in the know, bootstrap, and there's some good reasons for it that we'll talk about in a minute. So, the trip down memory lane, these were the 4 steps in regression in my master's program. This is what they taught us to do. This is how we tested regression, or mediation there. If predictor is linked with the outcome, the predictor is linked with the mediator, and if the mediator is linked with the outcome, and technically step 4 is hoping that while we're controlling for this mediator, so now we have the, let me turn my volume off. How about for you? But that little ding sound of the email coming in actually stresses me out. But the problem just happened for that. Just kidding. All right. And then we have our last regression where the predictor and the mediator are entered to the outcome variable, and we're looking to see if the effect from the predictor to the outcome was lowered. Does everybody if it was lowered. That was never defined or by anybody. When we did constrained it in SEM, that was a good step towards did it lower significantly. But this is always just sort of haphazard of, oh, it's down, I guess, a little bit from what it was. So independent variable, the predictor to the mediator, and the mediator to the outcome. These paths labeled A, B, and C. So if this C path here, sometimes if we were doing these several different regressions, the C path would go down to almost 0 and be non-significant. That would be how they, in the past, they would look at it to see if it was really a mediator, if it mostly took this path away. Full mediation and partial mediation, does this sound familiar to anybody? Probably. Yeah, I got this. So the full and partial mediation is probably easier to explain on this slide. But if the C path here is significant, then which way is that one? If this is significant here. I heard 3 people whisper it, and you're right.
If we were testing it,
You're saying if we're doing that full model and C is still significant?
Yeah.
That would be partial.
It's partial. So I don't know, it's so sweet to me when you're in a stats class, and when I teach a K-State, it's the same when you ask a question. Sometimes this happens. Everyone making good eye contact the whole time and smiling, and then you ask a question. And it's really discouraging as an instructor to ask questions. Like, you can be socially primed to stop asking questions as a teacher. But anyway, and the other one is when everybody whispers. And so,
like nobody wants to say, I looked at Jasmine, I was like, right, outside lane.
anyway, it's super endearing to me. 3 of you. And you were correct as well. Partial. Yeah, so if this is significant, it means it's a significant direct effect, but it's also significant through the indirect pathway. If C is not significant, that if this was significant before, but when we add in the mediator C is not significant, then it's the other way. What do we call that one? Oh yeah, Carmen said it first that time. Good job. The full mediation is when that direct effect is no longer significant. Which makes sense. If we add this one in, here, then this totally goes away because the path fully goes through the mediator. There isn't anything left to explain without the mediator there. All right, however, if you think about real life, there's not just one mediator, is there? There's a lot of mediators. There might be a lot of mediators between 2 variables, or there might be a lot of steps in that mediation pathway. So that's a problem for this method because then it would grow exponentially for every new leg of our mediation that we're doing another 4 regressions for. Just kind of, I guess that's what they used to do, but we're really lucky that we don't have to do that anymore. So the Sobel test, I believe Sobel was a person, but I honestly don't know. We always capitalize it, so I think that means person. So, oh yeah, no, we signed it Sobel. Yeah, so it was a person, I guess. So this is really testing that indirect effect with this little formula. If any of you are good with Excel and you want to impress your major professor, you can email your program and say, I made this document where if you just put in these 4 numbers, it's a Sobel test, and you can test this as significant indirect effect. But this is your formula for that. So, but some problems with the Sobel test, even though it's super easy to use. If you Google Sobel calculator, a bunch of websites will pop up. These are a couple of them. One of the biggest problems with the Sobel test is we're really not supposed to use it unless we have a sample size of at least 500. And it's on, which not always do we have sample that big. Sometimes it's only 20. So then we couldn't do this. The reason it needs to be that big is that indirect effect from A times B, literally this A times that B is the indirect effect. I don't know if it's on a future slide, so we'll say it right now. But how we compute the indirect effect is literally we multiply this one times that one. That's the indirect effect. So this is 0.2 and this one's 0.2. We multiply those together, it's 0.04. So we would say a 1 unit increase in our independent variable is associated with a 0.04 unit increase in our outcome variable via its previous effect through our mediator. All right, so here we go. So this is how the Sobel calculator works in a fake model with fake numbers. We have anxiety prior to first date for a sample of a bunch of teenagers, predicting volume of sweat, predicting perceived odor. Then this could be its indirect effect we wanted to test. If our beta, unstandardized betas, is what we plug in here, it's more accurate than the standardized, and it's what's meant to be put in here. For the A, for this pathway right here, the unstandardized beta is 0.3. We put, do you see it up here, the A, the B, the C? That's what we put in here, the A and the B. The unstandardized beta for A and B, and this B is 0.4, so we put the 0.4 there. The standard error of this path, if it's 0.1, we'll put a 0.1 there. The standard error is 0.12, we put the 0.12 there. And we click calculate, and voila, we report it as a Z. The Z in italics equals just 2.23, P less than 0.05. So you don't even actually have to have the raw data to do a Sobel test. You could run a Sobel test on whatever you want, as long as you have the unstandardized beta and the standard error, you can run a Sobel test. Why shouldn't we do it if we only have 100 people in our sample? The easiest answer is it's not 500. But the more specific answer, I guess, is these indirect effects. So let's say we have Alex's indirect effect. No, this is a weird, never mind. I'm not going to use your names for this one. Say we have someone named Harry, and for Harry's indirect effect, we have that this association, when Harry goes up 1 on this unit of anxiety, Harry goes up this much on his volume of sweat produced, that he went up this many cc's of sweat. But let's say somebody else, it was a little bit different. So for each person in our data set, there's different direct effects and there's different indirect effects for each person. And that's a normal distribution of those indirect effects. So the indirect effects, remember how we get those? It's this 0.3 times that 0.4. So if this was just one person, which is not, this is made up for a whole sample, but if that was just one person, that person's indirect effect is 0.12. But Evan's indirect effect might have been 0.15, Kevin's might have been 0.08. But we have this distribution of indirect effects. And it doesn't look normal-ish unless we have at least 500-ish. 500 isn't an exact rule, it's just more, it doesn't start to look like a bell curve unless we have that many people. But bootstrapping, you can do with just 10 people. It works out. Well, nothing would be good with 10 people, but it still could be done. Is that clear on how to run a Sobel test? And some of the problems with it, you can only have one mediator that we're testing at a time, and we need a big sample. So bootstrapping. Dun, dun, dun. Has everybody heard the phrase bootstrapping before?
Yes.
Sounds right. I've noticed there's a lot of good people in our field. I don't think they really know what it means, but they do know if you're testing an indirect effect, you should bootstrap it. I know professors personally who have no idea what it is, but I've watched them talk with students and say, that's not, you need to bootstrap that indirect effect. But I want you to know not just that you're supposed to do it, but also what it means to do it and how to interpret it and why it's important to do it that way. So, if you are reviewing a paper, it's a helpful thing to test it to bootstrap our indirect effects. And what's cool to me about bootstrapping, does anyone know who this most closely connected to, or who developed this as a way to test mediation?
Is that true?
Did you say Captain Sparrow?
Yes, Jack Sparrow. Is that a thing? Is that a thing?
Bootstrap bill comes in my head every time I say this out loud. Yeah.
I immediately think of Andy Field. I don't know if, did anybody else use Andy Field in their classes? Yeah. Because he like spoke a lot. Yeah, the whole book, and he spoke a lot about bootstrapping. That's all. And because it accompanied videos, so in our class we watched a lot of the videos of Andy Field and his cats. Doing his cats. Yes.
Sounds like a good stats video.
I thought. You didn't watch the YouTube videos? Yeah.
Cool. Well, it was really by a doc student, which I think it just makes me more happy. Someone just like you, just in his doc program and learned what bootstrapping was, and thought his name was Chris Preacher, Andrew Hayes, and wouldn't that be cool if you're just sitting around talking with your major professor and like, you know what, this is like a problem. Sobel tests, these 4 regressions, this is all kind of weak, really. I mean, this is as good as we can do at this day and age. But if you know what bootstrapping is, it's just a resampling technique that's been around forever. But if you know what bootstrapping is, you know how we do a little bit of narrative and a little bit of structural and a little bit of EFT mixed in, and we tie a bow on it and call it our way of doing therapy. You can do the same with stats. You can do, well, I know a little bit of bootstrapping, put a little bit of bootstrapping with my little bit of indirect effects, and I'm going to add on a little bit of this. And I think there's really exciting ways to grow when we start mixing models together. You put a growth curve in with an SEM, with a late profile analysis. So that you can mix and match, and we can do new things that we didn't think were possible before. All right, so bootstrapping is a way where we resample. So getting into what bootstrapping is. Now I hope it's burned in forever, doc students, just like you. But Chris Preacher is thinking, well, if we bootstrap, what bootstrapping is taking our sample. If we have 100 people in our sample, so when we run our model once, we click run on whatever it is that we're doing, and say we're running a regression. You can bootstrap a regression, you can bootstrap anything you want. But I believe in the future there's going to be some other doc student that's going to say, why do we only bootstrap indirect effects? We could also bootstrap interaction effects. And that would make just as much sense as bootstrapping an indirect effect for mediation, to tell you the honest truth. Why don't we bootstrap direct effects? That would make just as much sense, and it would also be just as valuable. But bootstrapping is a way, so everyone knows what replicating a study is, right? Where we have Dimaji who does a study and she says, look at this cool thing that I found. And then we go down the line and someone else studies it and replicates the same sort of thing. That's one form of replication. Bootstrapping, it's literally resampling from the sample that we have. Say we have 100 people, and we run it once with just 100 people on average for that 100 people. When we bootstrap it just one time, we're running it a second time, but we're randomly sampling from among that 100 people. So as we're picking, and we're getting other samples of 100. So instead of one sample of 100, we have now lots of samples of 100. But in these, if we bootstrap it 2,000 times, we have 2,000 samples of 100 that are all just a little bit different from each other, because it might be that Evan is in there 3 times in one of them. And the next bootstrap draw, he might not be in there at all. But it's randomly sampling from our group. If we have weird oddities in our sample, and our sample is small, bootstrapping actually capitalizes on that and makes it more weird. Because we're resampling those weird, if you have some outliers that are extreme in some weird ways, the bootstrapping, it makes it look even more odd and more extreme because that just keeps coming up bigger and bigger. But if you have a decent sized sample that's not too crazy, bootstrapping is an interesting form of, it's not replication because it's the same people, but it's reusing these same people over and over and over again. So if we wanted to predict sweat, whatever
Anxiety first aid.
Sweat or anxiety before your first date to predict how much you're sweating. We could do that with our sample of 100 and we could get one average beta. Or we could resample from our sample of 100 and run that 2,000 times with samples of our 100 randomly picked, sampling with replacement. Interesting, huh? And with bootstrapping, So we now technically, if we bootstrapped at 2,000, I'm not using my slides at all, I'm sorry. I don't know why I make them sometimes. It's for you to read later, I guess. But if we have these 2,000 different bootstrap samples, we now don't have just one beta from anxiety to sweat. We now have 2,000 betas. And we have this distribution now of the really low to the high. Does that make sense so far? Honestly, I think bootstrapping is complicated, to tell you the truth. It's running it, that's fine. I think but running it 2,000 times, like, whoa, it's a lot. Why would anybody do that? But if we bootstrap it 2,000 times, we now have 2,000 indirect effects instead of just one. And we average those 2,000 indirect effects, and the point estimate is how it's labeled in the output, is that midpoint kind of on this normal distribution we have of indirect effects. And the way we test to see if it's a significant indirect effect is, I don't know, I'm 10 slides ahead now. But if we are, so everyone remembers how confidence intervals work to some extent? So we've got this normal distribution. If within that 95% of the middle part of it, so within, every time I turn my back, another person walks out. This sort of thing conditioned faculty. Have you heard about the story of the faculty where the students were doing an experiment on their psych professor, where they ignored their professor when they were on one side of the stage? It was in some undergrad class I was teaching. And the professor is on this side of the room, just gets ignored, no one's looking. But on this side, everybody is. And the legend is that he just stayed on the far wall over here, because that was where he would be when everyone would listen. But anyway, sorry. So we've got this normal distribution. 95% is almost everybody that's right in the middle. So right here.
Our experiment is how much
you that? You should all do that. You should do that when you go home. Wouldn't that be fun? I'm sure your professors would love it. What's wrong with you? What's going on? So the point estimate is just this spot right in the middle. This is the lower 2.5%, the upper 2.5%. So let's say with that sweating example, that indirect effect, if it's an average of 0, it means that there's a 1 unit increase and our predictor isn't associated with any change at all in the outcome. So a 0 would be nothing at all. If it's something different than 0, it means there's an up or a down. There's some kind of indirect effect here. So with our 95%, it's this middle area. If the indirect effect is our 95% confidence interval, if it includes 0, it means there is no significant indirect effect. If 0, we'll say, is right here, 0 is in that realm of possibility within the 95% confidence interval, then we say there's no indirect effect. If 0 is out here, sorry if that's confusing, I have 2 zeros now, but if 0 is out here, it means that it's not within that 95% confidence interval, then it means we have a significant indirect effect. And the really easy way, again, 5th grade again, if both numbers are positive, 0 is not in there. If both numbers are negative, 0 is not in there. If one's positive and one's negative, then 0 is in there. So when I'm looking at it, are they both positive or both negative? And if they are, then it means I have a significant indirect effect, because 0 isn't. We're 95% certain that indirect effect is something other than 0. So we would say this is a significant indirect effect. And the super cool part about bootstrapping is you can have A to B to C to D to E to F to G. And we can test that whole indirect effect at once in just one model, which is kind of handy. We can test some models, you might have 20 variables in it if you have a huge data set. And you probably shouldn't have 20, that would be harder to write the paper for. But if you had all of those and you had dozens of indirect effects, you can test all of them with the one run, which is in your one set of output, you'll have all of those indirect effects for you, which is really handy. All right. Questions so far? All right, I want to go back to the slides and see which parts I missed. Okay. It's computationally intensive. Before cool computers, we wouldn't have been able to do this. Some of you are going to test really cool models that are going to take a couple of days to run if you're bootstrapping it a couple thousand times. A simple model will be done in 5 seconds. A really complicated big model with a huge sample, especially if you're doing mixture modeling. Kasha, you know Austin. Sweet, lovable, wonderful Austin.
Yeah.
Yeah. Days. Many days. He was connected to our supercomputer at K-State. It's the only computer in Kansas that's a supercomputer. But it's a computer that can do anything. He got special permission to use the supercomputer, and it still took over a week to run things. That's how you know your model is really, really complex. So proud of him. So happy he's done.
Yeah. Hey, Matt,
Yes.
he's a doctor. That's what you have to do to become a doctor.
His supercomputer.
Yeah, bless his heart. I'm so happy for him that it's finally done. It was a big job. But anyway, with bootstrapping a complex model, because remember, if it would take that complex model a really long time to run once, we're asking it to run thousands of times, which takes longer. But we don't just want the output once, we want a bootstrap sample of our output. All right, so we're estimating thousands of times this indirect effect. We focus on the indirect effect, but honestly, we're bootstrapping every single part of the model. All of the output is getting bootstrapped. All right, good. Bootstrapping helps us with the power problem, like the Sobel test needing 500 helps us with that. We have enough power with even a smaller sample. We talked about the 95% confidence interval of these indirect effects. And I think we covered this part already, but I'm just going to briefly go over it since it's here. Maybe the second time will feel even better. So in this example, I have 1,000 bootstraps. And this is actually from the Creature and Hayes article. This is their example. But in 1,000, we did 1,000 bootstraps. We have 1,000 of these A times B, 1,000 of these indirect effects computed. To derive the 95% confidence interval of these 1,000 different bootstraps, this 1,000 different sets of output, with 1,000, the 95% confidence interval corresponds with the 25th score. So if we, in order, started with 0 all the way to 1,000 and ranked ordered the effect sizes of these indirect effects from the smallest to the biggest, it'd be the 25th from the bottom and the 976th from the bottom. That everything within 25 and 976, that's our 95% confidence interval. Using the same logic, 99% confidence interval would be the 5th and the 996th. If 0 is not included within this 95% confidence interval, we can conclude that this indirect effect is significantly different from 0. If 0 is there, it means you've got nothing. Have you asked your cell phones, have you asked Siri what 0 divided by 0 is?
You want us to?
No? No. My kids do it all the time. Maybe it's not an adult thing to do. But if you have 0, there's nothing. There's nothing there at all. That's pretty funny, actually, if you're a parent or a kid.
Did she say nothing?
I want to hear.
Yeah, now I'm curious. Did she say nothing or did she talk back to you?
Talks about Cookie Monster and you have no friends, and you have no cookies and no friends. But anyway. But if 0, and this applies to any confidence interval at all, if 0 is within our confidence interval, it means that there's nothing there. There's nothing going on. Yep, there it is.
Jared's correct.
All right, you'll have to listen to it later too. But, so if 0 fits within the confidence interval, it means there's nothing going on. Well, there's no indirect effect. covered here. So we can test all of these mediators at once. And it's really better science to test them all at once than to test them one at a time. Some benefits. Each mediator is going to affect the other betas in the model, just like a control variable. Have any of you run a model and then added a few controls and it just dramatically changed what you're really excited about? Like, oh, man,
Yeah.
there it was. I had it. And then your major professor today says, well, you didn't control for this or this or this, you need to control. And then it changes and it goes the other direction or the effect goes away. But including other variables of interest makes our models more accurate. Unfortunately, it's not always the way we want it to be, but adjusting for those things, if we were, like if I was trying to predict how well you were going to do at paying attention to a stats workshop at 6 o'clock at night, if I don't control for what you did the rest of the day, that model is flawed a little bit, isn't it? If I don't control for how much you slept last night, for the last few nights, stay up with my roommate, we talked about solution-focused therapy till 4 in the morning. Awesome. We figured it all out.
We figured it out.
But those things change everything else, doesn't it? When we control for different things, it changes. And it's the same with mediators. In real life, there's a bunch of mediators. If we don't include them all at once, our models aren't quite as accurate. We get to see to what extent one mediator has a larger effect size than other mediators. As a therapist, I want to know where's the largest effect sizes so I can work with those. We just talked about that. And the relative effect size. Okay. I think we're going to have enough time to do this, I believe. 30 minutes. Probably be done. All right. How many of you have M+ downloaded to your laptops? Can you raise your hand and hold it for me for a sec? Sweet. Everybody. How many of you have Macs? Can you leave your hands up?
Oh, excuse me, no, Surface, thank you.
Works hard.